Hello, this is Mr. Ellison. Today's podcast is on topographic maps. So what is a topographic map? Well, this is a topographic map. You may have seen one before. More specifically, this is what we call a 7.5 minute map, meaning that it is 7.5 minutes wide in terms of its longitude by 7.5 minutes long in terms of latitude. Notice, by the way, that it is not as wide as it is long at this point, even though they're both 7.5 minutes. Something to wonder about. All right, so a topographic map is no different from a normal map in terms of the things we would expect to be there. Names of towns and their locations, bodies of water, roads. But the difference is that topographic maps have these little brown lines on them that we call contour lines. What are contour lines? Well, contour lines are lines that connect and indicate areas of equal elevation. Because of that, topographic maps show the topography or shape of the land. They allow us to see the shapes there in a two-dimensional form. So let's take a look at this. So what does that mean? That means that on this map right here, for example, see that brown line I'm pointing to, that all the values on there are worth 350 feet. All the elevations there are 350 feet. It's there, 350 feet, and right there, 350 feet, right there, and right there. Every point on that line is 350 feet in elevation. What are some of the values of the other lines? Well, it's difficult to tell, except some of these are labeled. We like showed you there, they have the 350 feet labeled. We also have this other one near it that's labeled 400 feet. Okay, but what are the values of the ones in between? Well, we could kind of subtract the two and maybe kind of figure it out, but there's actually a much easier way. All you have to do is look at the bottom of the map for what's called the contour interval. And the contour interval is located right there at the bottom of the map beneath the scale. And here it says that the contour interval is about 10 feet. So what that means then, well, let's actually talk about, first of all, the definition of a contour interval is the difference in elevation between two consecutive contour lines. Difference in elevation between two consecutive contour lines. So what does that mean? Well, what that means is that if this line right here is 350 and this one is 400, each line in between there, we said, is worth 10. So the next one up from 350 will be 360. The next one up from 360 will be 370, 380, 390, and of course we've already labeled 400. Each line is worth 10 because the contour interval is 10 feet. It's not the same for all maps, but this map, it's 10 feet. Okay, like I said, contour maps let us look at, topographic maps rather, let us look at the shapes in a two-dimensional projection. For example, hills are represented by contours that are arranged in a circle. This is the hill just outside of the school, just to the south that Bray Road goes up. And as you can see, the contour lines are going in circles to show us that there's a hill there. We can also identify river and stream valleys or stream lower areas that streams have carved out by the fact that as they cross the contour lines, they make a V shape. Can you see the V shape here and here? There's a V shape there. There's a V shape right there. Okay, there's another one right there. The V shapes are formed when the contour line, when a river valley or a stream valley crosses a contour line. So contour lines form a V shape when they are crossed by a river or a stream. The important thing to remember, and this you might want to make an extra large note about this, is that the V always points upstream. The V always points upstream. So let's go back here for a minute. So what we're saying here is, see these V's right here? There's a V right there. There's a V right there, if you can see my mouse. There's a V right there. There's a V right there. Those V's are pointing upstream. So the source of the stream is up here, and they're flowing downstream this way. And that makes sense because they're going from areas of higher elevation, 400, down to areas of lower elevation, 350. Okay, and this is a big swamp out here. Okay, that's very important. Very, very important right there. Make sure you write it down. Depressions or pits can be identified by what are called Hatchard contour lines. So here's the quarry, the Barrett's Quarry we went to just the other day for a field trip. And if you look closely, you can see these little tick marks that are pointing out from the contour line. This indicates that the elevation there is going down in towards the center. Okay, and those of you who are familiar with the quarry, obviously that makes sense, right? We saw that with our own eyes. So we can recognize depression or pits by the fact they're marked by hatchered contour lines. Those are contour lines with ticks pointing to the center of the pit. Okay, so that's just going back here to Barrett's. We can see that this large pit representing the Barrett's quarry, those tick marks point in towards the center. That's how we recognize depressions or pits on a contour map. Finally, last thing I want to talk about for a topographic map is what's called the gradient or slope. Okay, we can recognize the gradient slope two ways. We can look for how close the lines are. For example, over here at Barrett's, if you look closely, those contour lines are very close together. That means there's a very rapid change in elevation over this distance. And those of you that have seen this, we've seen it before, you know it's very steep right there. Someone keep telling me about how deer like to often jump over this hill, not recognizing that it's quite a steep drop off on the other side. And well, there you go. However, over here in this area, notice there's no contour lines here at all. For those of you that are cross-country runners, you've probably been up in this region here. Notice that the contour lines aren't there. That indicates that that's a very flat area. There's no change in elevation. Okay, so what we're saying here is that contour lines that are close together indicate a large change in elevation over a certain distance, meaning it's steep there. But contour lines that are far apart, that indicates a small change in elevation over a certain distance. It's flat there. Make sure you write this down. Okay, we can also calculate gradient. And what I want to look at is I want to look at this area right here. See the power lines here? Once again, those of you who are cross-country runners, you probably know this. I believe you call this Swear Hill right here. Pretty steep right here. We're going to calculate the gradient from here. So we're going to start here, right here where the power lines cross the 400 contour line. We're going to go down here to the 350 contour line, a straight line. And we need to figure out what's the gradient there. Well, how do we calculate gradient? We calculate gradient this way. Gradient, or also known as slope, is equal to the change in elevation divided by distance. Okay, so what was our change in elevation? Well, we went from 400 feet to 350 feet. The distance that was, I measured it on my map, is about 1,000 feet. So gradient then becomes 50 feet divided by 1,000 feet, or what it works out to be about 0.5 feet per feet. Okay, so what that means is for every foot that I go across, I'm going up 0.5 feet. Now, if you've ever run up that hill, you probably think it's a lot steeper than that, but actually no, it's not that much steep. It's not that steep. So every foot you go this way, you go up 0.5 or 5/100ths of a foot in elevation. That's basically what gradient is saying. Okay, so that's right there what we're just saying. Every foot we go this way, okay, we're going up by 5/100ths of a foot. That's the podcast for today. Make sure you understand how to calculate gradient, how to read Topomaps. We're going to do that tomorrow. We'll see you tomorrow.